Hey guys, what's up? Eddie Aho here with KissAnalog.com. Hey, it's time for a rant and a leffy. I don't know how to pronounce that. You know, I went to France and I had one of these beers and it was really great. So I thought it'd be good for this video because I don't know why, just because. Anyway, I want to talk about EMP, Electric Magnetic Pulse. Okay, you've probably heard about this. If you haven't, it's where, you know, say a nuclear bomb goes off. Now that would be an N for nuclear EMP, because you can also have EMPs from a sunburst, okay? You can also have a HEMP for a high altitude electric magnetic pulse. Now what that would be is where, you know, essentially, let's just say the air gets ionized with, you know, real heavy electron pulse, okay? And it goes into all our electronic devices and kills them. So people want to put them in these bags that you can buy on Amazon, or you can buy these devices to hook up to your, you know, solar powered generators that you're buying just because of a situation like that where, oh, you don't want to be without your generator, you know, during a situation where the world's gone to hell, you know, and you got to have your electronics, right? Well, let me just tell you that it's all BS, guys. It really is. So I've been an engineer for many years, and I've worked in defense industry for a lot of those years, and I actually worked on a program that was a very expensive program, and I'm not going to talk a lot about it, but all I'm going to say is it had to do with protecting the communications for the president on his plane, other planes, ground communications, Navy, you know, anywhere you have communications that the president has to talk to, they'd be hardened for this kind of a thing. Now, what we're talking about is the guy in charge of the country having his radio gear, you know, his communications working, right? Well, you know, the government has to plan for the most minute chance of anything happening. Because we have taxpayer dollars that can afford all this stuff, well, at least they think they do, that they can spend it. Anyway, they got a budget that is non-ending, right? They can do what they want to do. So they can do those kind of things, and we want them to do those kind of things because we want to be protected. We want to think that, you know, that we're doing the right thing, right? But for us individuals, the chance of any of those things happening, any of those events happening that would actually kill your electronics is infinitely small. And so it's much more likely that the grid would go down, that you would want something like this EcoFlow. You know, you'd want these kind of things. You'd want to spend your money on another one of these versus those other things. I mean, if you think that your money's well spent there, you should buy lottery tickets because you have a much better chance of winning the lottery. I mean, for hell's sakes. First of all, a lot of the devices they're selling are worthless. Okay, so I was getting ready to do some other videos, and then this topic came up and just kind of drove me crazy. So I wanted to do a rant on it, and I just want to talk about it because I do have firsthand experience in this. I understand the electronics. I understand what you have to do. I've designed things for space. I've designed things for this kind of situation for the military. So, by the way, the documents that tell you the energy and all that stuff that you'd have to protect against are classified. So the stuff that you can buy as a citizen is you can't even know that it's going to work, and it won't work. I mean, well, okay, let me say the aluminum foil or a bag around your electronics is going to work as good as anything. Those electronic devices that you're going to hook up to an energy thing like this are absolutely worthless. Well, they're not worthless. They're a nice filter, if any. I don't even know if they're a nice filter. I haven't tested the filtering aspect of them. Well, okay, that's a lie. I actually have, and I haven't seen them do any good. So they're not even good as a filter. I didn't see any difference from radiated emissions when I did some testing. So if you wanted to protect, if you're going to install some product in your car to protect your car, I've do a lot of research whenever I do videos like this. And I've watched a lot of videos on YouTube. I have hours of videos, honestly, hours. And so that's one reason why it's been a while since I've done a video, because there's 2 or 3 subjects I'm going to do videos on in the next few days. And I've just done a ton of research. That's what I do as an engineer. I'm a research guy. So I research things. And even though I know a lot on the topic, I just want to make sure I actually know it. So I want to look at all the current information to see if there's something I'm missing. And I haven't seen anything. I've seen things that just make me cringe. Make me want to do a rant video. Oh, wait. Yeah, so I'm doing a rant video. Yeah, so there you go. Maybe I should have a few more of those. Maybe I could be a little smoother. Anyway, so let me tell you something, guys. Those things I've seen guys install in their cars. So just to tell you some background why I know this stuff, is not only have I designed things around these electric magnetic pulse issues, I've also been one of the few guys on this planet, I think, that has been UL certified, for I think it's 5 or 6 years or something like that. Worked for one of the bigger electrical companies in the United States, well, actually in the world, because that company is bought by a company that's worldwide known. And we did things for electronic surge, okay, for electrical surges. And they're very closely related to this EMP thing, okay? Now, when you see specs that say 1 nanosecond, it's absolutely BS. Absolutely BS. I can show you the math. I've done white papers on this, actually, and I've shown people why we shouldn't use this. Now, I used to joke around with the marketing guys. I used to say, oh, you got your marketing calculator out? Because we engineers don't have that calculator. We don't know where you're getting these numbers. Anyway, 1 nanosecond. If you look at the test data that these devices say that they've tested to, you can actually trace it because the lab has to provide it, because it's a public safety thing. So you can go to the lab, you can pull down the specs, and you can look at it and read it for yourself, and you can look at the graphs. Now, when they say 1 nanosecond, let's say that I turn up the voltage, or I flip a switch on. What they're doing, as soon as they see that flat line, 0 volts, as soon as they see any voltage movement at all, they go, oh, there it is, I saw it, 1 nanosecond. That doesn't mean anything. What you care about is what voltage it rises to that can cause an issue. And guys, that is not 1 nanosecond. That is way longer. So here's the other thing, is tell me what device that you can buy in the world that operates, that can clamp or protect in 1 nanosecond. There are none. There's 0. We used to call them transorbs back in the day. Now we call them transient voltage suppressors. There's a company that trade named it Transorb, so everybody call it Transorbs. Kind of like Sony Walkmans. They own the name. Well, if you're old as me, a lot of you younger guys won't even know what I'm talking about. But the cassette decks. People would carry around portable cassette decks. Everybody referred to them as Walkmans. Well, that was Sony's brand, because they came out with them first, and they made such a big splash, everybody just called them Walkmans. So I bought a Hitachi, but if somebody say, hey, let me see your Walkman, I'm like, well, it's actually a Hitachi. So the point is transorbs are called TVS, transient voltage suppressors. They're kind of like a Zener diode, but they're different. They actually operate a little bit differently. They're very fast. So they're similar to a Zener diode in the way that they clamp a voltage, but they just do it very quickly. And so that's why that's the difference, okay? Anyway, look at the data sheets. Look for yourself. Look where they clamp. It's not 1 nanosecond. They might even claim 1 nanosecond response time. That's just like I said before. When you hit that switch and you see on your scope that something moved, as soon as they see it move, they call that response. Oh, 1 nanosecond. Well, okay, yeah, but first of all, if a voltage rose that quick, there's a formula called V equals L di dt, okay? So if dt is 1 nanosecond, then anyway, what it means is the voltage would have to be gigantic. And it's not, because it's the response. It's right when they barely see any movement. So anyway, the 1 nanosecond, whenever you see that, or even any nanoseconds, it's BS. And that's not what we designed to. I can't tell you the times we designed to, but I can tell you that they're much longer than that, okay? So it's not even a thing. So here's the other thing, is V equals L inductance di dt. That inductance, if you're trying to protect something, let's say a USB port, you got to put your transient protection device, your TVS diode, really, really close so there's no traces. You know, you don't want a 1/2 inch of trace on your circuit board, let alone a foot of wire. So when I see these devices sold, they have like this long wire, and people, I guess, well, there's connectors on the end. So you wouldn't think, oh, I'm going to place it really close to what you call the victim, the thing you're worried about protecting. You put it very close to the victim and you tie the wires very close to it. Well, every inch counts, okay? So now I was actually hit by lightning. Well, not me, but my car was. Okay, I was driving a nice Land Rover, brand new, and it got hit by lightning. Imagine that. I was working for that company I'm telling you about, where I did lightning protection. So I think it was Thor saying, here you go, engineer. Poof. I can give you a taste of what I could do to you if I wanted to. Anyway, it killed my car. I was coasting down, felt like somebody with the big phone book hit me over the head. I actually saw the flash, and then I think I was dazed or knocked out. And next thing you know, I was trying to figure out if the car's running. Short story is, it knocked out 7 computers in the car, because there's a lot of computers. And this was years ago, guys. This is 2004. So the newer cars even have more computers. But it knocked out 7 computers in the car. It knocked out the ABS, or the wheel sensors on all 4 wheels. Okay. Plus it knocked out some lights on the dashboard. Okay. So if you're trying to protect your car so it'll run after an EMP, and you put some silly device inside your engine block next to your battery, waste of time, waste of money. And hey, if you did a YouTube video on it, shame on you. You just led a lot of people astray. Now, you didn't know any better, so okay. So, but still, do some research, you know. Don't go tell people to spend $300 or something on some device that has zero meaning, zero effort. That's going to do zero for them. It's just an absolute waste of money. So if you were going to try to protect your car, the people designing the computer boards that put them in your car, they would have had to put those TVS diodes on those boards, which they did, because automobiles have a lot of surges going on. When you turn on the car, when you stop it, the alternator, the starter kicking on, they're protected. Okay, they're already protected. If you want to add further protection, you would have to have at least 7 of those devices placed right next to each computer. not next to your battery, not connected to your battery. Your battery is not the thing you're trying to protect. Your battery is a low impedance power source, okay? So if you're worried about killing your battery, well, you've just killed every other thing in your electronics. There's nothing that's going to work in your car. So, and besides, you want to be the only guy driving around a car that's working when no one else's car is working, you're going to be stuck on the freeway. So put an electric bike in your car, or put a bicycle with no electronics and hop on your bike and ride it. Put a backpack and a bike in your car if you're thinking that way. It just bugs me because I hate to think that people are wasting money and these companies are basically stealing money from people. They're providing goods that mean nothing, that won't do anything. Now, obviously, all this is a rant, and this is all my personal opinion, and I'm not saying I'm credited by anybody to be talking about this, but I am trying to tell you that I have some kind of background and that I might know a little bit more about this stuff than anybody else on YouTube that I've watched. There's a doctor that's talking about this, and he's probably the most credible person I've heard talk about this, but every video I've seen, he's selling bags and he's selling things. So even that guy, I'm like, so if you put a radio and you put something outside and you try to show the two radios stop communicating, that's low energy signal, guys. That's not an EMP. Okay? So that kind of test doesn't prove anything. It's not proving anything. All right, so you want to protect your EcoFlow, all right? Because this guy, hey, I got to turn on the screen. This guy, I love this EcoFlow. So you want to protect this. Well, I want to protect it. Well, if you want to protect that thing and you put this guy connected to it, this EMP device connected to it, that's not going to protect it. All right, so there's two things I want to talk about. And I guess this video is probably getting too long. Sorry. All right, guys. There's two ways that... Now, I'm going to do a video on EMI or EMC. All right? And there's two things that can bother electronics. You guys have probably seen, maybe... You're watching a Super Bowl, you're watching a football game, your wife starts to vacuum and you see some static. Today, that's less likely, so maybe you don't even know what I'm talking about. Somebody turns on a blender, maybe, something like that. Something with the motor, usually with the motor, that causes some electrical interference on the power lines that gets into your television or something like that. That's called conducted emissions, okay? So those things you attach to your device, that through the cable, that's the idea is they're going to protect this device from a conducted emissions. Well, that's one way an EMP could hurt your device, but really, if you are going to have an EMP strong enough to hurt your device that gets by the protection that's already built in, then there's the radiated emissions, what's coming from the air, okay? Just like if you pass, you've seen things like where you pass some electronic device by an antenna on a radio or something, and it picks up that noise. That's radiated emissions. So these days, now this field here, there are some products that are actually tested, okay? A lot of products, I'd say the majority of them are started by startup companies, and they're new companies. This is a brand new field, even though it's exploded over the last couple of years. There's a lot of the companies now that are being tested they're testing themselves. So they have certifications that show that they don't radiate, for one thing, and they don't put conducted emissions on the line, but they also are not susceptible to the conducted emissions coming in or the radiated emissions going into it, okay? So if you put one of those say $300 devices on your product, you're hoping to protect it from the conducted emissions that are coming through the wall. Well, you know what you do to protect that? You do this. You store it this way. Problem solved. It's problem solved right there. This wire can't put anything into here. Ay, ay, ay. So that takes me to another subject. Well, let me finish this one. So that's conducted. The other one's radiated emissions. That's one you want to worry about, okay? Now, this is plastic. A lot of the better products, I think, are plastic, and there's safety reasons, I think, why that is, so you don't get shocked when I touch this metal and this plastic. I can't get shocked between these two things. If this guy's not grounded, and this guy is, and there's a problem, I don't get shocked, okay? So I think that's one reason plastic housings are popular on these generators, these solar generators, people refer to them as, because you normally would have a solar panel hooked up to it, so it's generating, you know, electricity from a solar panel, although they can be charged like I'm doing right now from this electrical cord. So radiated emissions is what you'd mostly be worried about. It's the radiated emissions coming, like that thing I was talking about, your car. How do you think your car is going to conduct electricity from an EMP up into it? So that's really ironic if you think about it. That company that sells things for your car, it's radiated. First of all, it's radiated up into the cables. The cables would absorb this radiated energy and then send it around your car and kill things. Well, you're putting it by your battery. So first of all, you're protecting the wrong victim. Your battery's not the victim that's most likely to die in that scenario. But that would mean that it would have to be conducted from, you know, some electrical wave coming across the ground up into the tires and then throughout your car. That's conducted. Well, your tires are rubber. I've heard people say, yeah, but they're made from carbon and that's conductive. Well, go take your ohm meter. There's lots and lots of ohms there, guys. It's not, your tires are going to protect you. Believe me, okay? They don't protect you from lightning. Lightning has a ton more energy, tons and tons more energy than an EMP. You get hit by lightning, I don't care what protection you have, it's going to fry everything, okay? So people think that the tires protect them from lightning in a storm, or from, but then somehow they're worried the EMP is going to come up to their tires and kill their car. That's kind of crazy, right? But neither one of those two things are true. First of all, EMP is not going to come up to the rubber, through the carbon in your tire. And by the way, your tires, the reason you have to put that stuff on to blacken them, because they don't put as much of that compound in the rubber as they used to. Like, this has been 15, 20 years ago. So, you know, you have to put armor on your tires to make them black, because that stuff that made them black before doesn't make them black anymore. And tires, you know, 5-7 years wear out regardless because of that. Anyway, that's another side thing. But the point is your tires are not going to conduct an EMP up through them, okay? The lightning hitting your car, like in my case, hitting my car directly right above my head, I was protected because I was in a Faraday shield. The car was basically aluminum. Land Rovers were made out of aluminum, okay? So I had an aluminum shell around me. Yeah, there's glass, but mostly aluminum. So the lightning went around the aluminum. You know, my arm kind of felt sore for like a week or two after, probably because of electricity going through the body of the car. Probably, you know, that, I don't know, it just, maybe it was in my mind, I don't know. But that left arm kind of felt numb, kind of weird for a while, kind of ached. But, and it did feel like a phone book hitting me on top of the head. It was like, kind of dazed me. It took me a while to kind of come to. I was trying to figure out if the car's running and all that kind of stuff. What protected me is the Faraday shield. So what you want to do is protect a device like this, is like those bags, if they do work, You could make your own. You could get a plastic bag, wrap it in aluminum foil all the way around it. Take another plastic bag, wrap that around aluminum foil, and then take another plastic bag. Now you got 2 layers of aluminum with plastic between. The reason why you want the plastic between, you don't want the 2 pieces of aluminum shorting in different places around there. You want them a continuous aluminum, sheet, Faraday shield around each one. I mean, I'm just saying that if you were going to buy a bag, you could make your own, okay? You could just get a metal foot locker or even your metal car and put your devices in those things, okay? Walkie-talkies, whatever. Here's the thing. Now, in a case like this, I can't take the battery out, but my walkie-talkie, something, things like that, I can take the batteries out. If you don't have your device powered, then it is very unlikely it can be damaged, okay? So that's one of the ways you protect something, is to take your batteries or disconnect your power source so it's not powered. So if an EMP came and it ionized the air or whatever, and it created like all the circuits in there to want to short, there's no power on there to short. And there's not enough energy in the air to actually fry your electronics. Well, and if there is, there's nothing you can do about it to protect it anyway, except for putting the Faraday shield, putting it in a metal box, putting some copper tape around the lid and cutting, taking away the paint, whatever. So something like that. So if you're worried about it, buy yourself an aluminum box, put your stuff in it, and that stuff would be protected. But buying those silly boxes, putting them on your devices, yeah, there's a lot of waste of money. It's fear mongering, guys, because there's a lot of talk, there's a lot of concern. Sorry about that, my memory card died. So anyway, what I was saying is, I was raised during the Cold War, right? Nuclear weapons, everybody's afraid of that. So let me just tell you that the EMP stuff out there, the best, I would say, first of all, disconnect your power from the devices you're worried about. Putting those conductive things on there, just get good filters, power strips with good filters on them, surge protection, and you have the little switch on the power strip, right? You can turn it off when you're not using it. That way you're protected from conducted EMP. Radiated EMP, if your device is turned off, if you have your batteries removed, if the power is disconnected, they're going to be protected to a large degree, maybe completely, but they're going to be protected, okay? And way better than putting some device on them, okay? The only other way to really feel good about them is to put them in a Faraday cage. Have a metal locker or something like that you just store them in. Now, for an EMP to get through your house and into your metal locker, that's a pretty strong field. So if you have something like that, good luck. Have a slingshot. I mean, seriously, you're wasting money. Spend money on things you can use, like these EcoFlow devices. Things like that can power your devices when power drops out. That's much, much more likely to happen than an EMP. So don't waste your money on EMPs. Buy an EcoFlow station. Buy a Delta Pro. Buy one of those stations that can power devices, okay? Buy some solar panels, some flexible solar panels, like the one I showed on this EcoFlow River 2. If you haven't seen that video, I'll put the link down below for that. But yeah, things like that, guys. Anyway, I just had to do a rant because I'm going to do another video on EMI and just kind of talk about that. Let me know what you think about that, and if you have any questions about this EMP stuff. But here's the thing. A lot of the videos I've seen showing people using the EMP device, they even themselves say they don't know if they'll work, And the way they install them, coiling up all the excess wire, those things will not work when you install them that way. So anyway, I can go on and on about that. That'd be very short wires right next to the victim. And even then, I mean, it's only going to protect conducted emissions if it will do that. So It's really just a waste of money. Don't spend your money on those things. Buy a metal locker that you're going to put like some ham radios in, things like that. It's the wires, antenna, things like that that are going to, the emissions conduct to, and you, like say a wire, long enough wires give me like an antenna. It's going to concentrate enough energy that maybe it travels down and hurts your electronics. So your cell phones, chances are they're going to be just fine, because there's nothing small, you know, you just can't pick enough radiation up to hurt those things. If they do die, they die. I mean, the satellites might be dead. They're not all going to be dead, and if they are, it's going to be temporary. So the best thing to have is ham radios, I think, walkie-talkies, so you can talk to each other, talk to family or stuff like that. But anyway, put those in a metal box somewhere. Take the batteries out of them. If they have lithium batteries, rechargeable batteries, well, then just put them in the metal container, and they're probably going to be fine. Put something like this where you can charge them up, you know, and you should be fine. Have some solar panels you can use. Disconnect your solar panels from your device and just have those as backup if that's what you're worried about. But like I say, the chances, you know, you may as well buy a lottery ticket if you think you're going to get hit by an EMP. So the solar panels you have out in your, you know, yard or whatever on your roof, you would need to have a device next to each one, because the length of wire between each one can be enough, you know, can build enough field up that might be able to cause some damage to things. But definitely when it comes in your house and you have one of these EMP devices connected between that power and your device, it's not going to do any good. First of all, the EMP devices I'm thinking of, they're all made out of plastic. So if this was my bunker and I was trying to protect everything in here, I would want a metal box with some protection inside it, so that it had to go through that and then get through that, and then I have clean power on the other side of that. But when you have plastic boxes and that, it's funny because those things are trying to protect the conducted emissions, but they themselves might be damaged by the radiated emissions. So yeah, it's just all a waste of money. Just had to rant. My feelings, my thoughts on the subject. Take it for what you will. But, you know, I think I probably have as much credibility as anybody else out there that I've seen on these videos. So fear-mongering. Don't be afraid. If you are, just be prepared with things like this. You know, we just had a huge snowstorm and knocked power out in parts of California. Those kind of things happen. So have some backup power. And you know what? If power's gone long enough, people say, oh, get a gas-powered generator because they last longer than these electric generators. Well, that's kind of true, but eventually you're going to run out of gas. Solar panels are the way to keep regenerating power, and that's why they call these solar power generators, is because you can have solar panels and keep regenerating that over and over. You know, might take you longer to generate the electricity, cloudy or whatever, but if gas is gone, solar is the king. So, all right, guys. Hey, thanks for spending the time with me on this rant. If you've stuck it out this long, 2 thumbs up. My patrons, as always, appreciate you guys. There's YouTube, put that thank you button down below. Appreciate you hit that. Hit the subscribe button, and I'll get some videos out quick. I'm just had to get this rant video done after I ran into so many videos after doing all the research on EMC and EMI type stuff and grounding stuff. That's another thing. I've done a couple grounding videos. I feel like I need to do a rant. So thanks, guys. Have a great weekend. We'll talk to you later.